I'm looking at the sample variance from 9.1.2. Not sure what page that is. That's page 262. And or if you're looking at a reader, it might be actually that you want to go to 279. So I looked at this and was and mentioned that I got confused about some algebra. Well, it hit me that I know what they did. They just didn't talk about it. So we want to look at this sample variance S squared, and our definition is 1 over n minus 1 sum I equals 1 to n, and that's of our xi's, our data, minus the sample mean squared. And then now the trick is to add 0 to this again, so that's 1 over n minus 1. The sum I equals 1 to n. And we're going to subtract m, which is the mean of the distribution, and then add it back in. But when we add it back in, we'll put it inside this minus, so it will look like a minus. And so we have that thing squared. Then the idea is that this x bar we can rewrite as a summation. So this is sum I equal 1 to n. So we still have our xi minus m, and then minus, and inside here we have the sum, 1 over n times the sum j equals 1 to n of xj, so that sum, and then minus m, all squared. But now I'm just going to fix this. I'm going to make this m, I'm going to divide it by m and n and multiply by n. And so then I can factor out the 1 over n, and I can think of m times n as m plus m plus m plus m. In other words, a summation. And so this is 1 over n minus 1, sum I equals 1 to n of the xi minus m minus, and I have the 1 over n that I factored out, and then the sum j equals 1 to n of the xj minus m, like that, squared. Okay, so I can write it like that, and I believe in the textbook they show this line. So I'll try to show lines that they had. So they showed this, and of course they started with that definition, but they were missing this one here. So missing that one. Okay, so now that we have this, then what they did, I'm sure, is actually do that squaring of that whole thing. So we've got equals 1 over n minus 1 times the sum I equals 1 to n. And when we square it, we just have a binomial with this minus in here. So we get our we'll get our xi minus m, we'll get that squared. And then we'll have minus 2, and it is indeed minus 2, minus 2 over n, xi minus m times the sum j equals 1 to n of the xj minus m. So we have that part, that's the middle term. And then plus, I'll put it down here, plus 1 over n squared. And we have the sum j equals 1. Well, I better put some parentheses around this. J equals 1 to n of xj minus m squared. Oops, not squared there, sorry. Parenthesis around that, n squared. And then the close of the square parenthesis. So we have that. Now, if you take the random variables and subtract their mean and sum them up, you should get 0. So now actually notice that you know, we get this, we can just call 0. Well, we could call this other business here 0 as well. And but the problem is if we just do that, we don't quite get to what we want. But recognizing that we have that sum xj minus m, and that's just 0, well, I'm going to just take one of them and make them 0, right? I'm going to, so, you know, I've got this term that I'm just going to ignore now. I have 1 over n minus 1, the sum I equals 1 to n of xi minus m squared minus, and I'll take one of those 1 over n's, and the xi minus m times that sum, j equal 1 to n, xj minus m. So I'll take one of those, and then minus the other one, 1 over n. I'm going to go dot, dot, dot here, because I don't want to rewrite that whole thing. But I'm just going to get rid of that because it's 0. So, you know, that thing's just a 0 there. But we're just trying to get things in the right form here. So we're trying to get a form that we're going for. And so now we're left with this business here. And in this case, what we do, okay, so I've got a 1 over n minus 1, and I have the sum I equals 1 to n of xi minus m squared. And then I have, if I move that sum through in the 1 over n, I have a 1 over n minus 1 times 1 over n, because I can factor that out, times the summation I equal 1 to n of xi minus m times the sum. Now all this is inside the sum of the i's, so j equals 1 to n of xj minus m, like that. And they don't quite have that in the text yet. That's still missing. But then this is equal to 1 over n minus 1, the sum I equals 1 to n, xi minus m squared. And again, I guess I just realized I sort of glossed over that whole thing. You know, the trouble I had in class was I knew that we had a 2 back here, and I didn't know what to do with it. But since these things are 0, I can get rid of any parts of them I want. So I just, since I had 2, I'll get rid of one of them, but keep the other one to get the right form that I want. And so, okay, I have this, and then this is plus 1 over n minus 1 times 1 over n. Now, on the summation up here, so for I equal 1, I'll have x1 minus m. So from this first part, I'll have x1 minus m. And then that's times, here with the j equal 1, I'll get an x1 minus m. That will be x1 minus m squared. And then plus x1 minus m times x2 minus m, x1 minus m, plus x1 minus m times x3 minus m, and so forth. Well, so what I'm going to do is I'm going to take the parts where I would get xi minus m times itself squared, and then take all the other parts. Okay, and all those other parts are going to be of the form the sum I equal 1 to n of the xi minus m, and then times the sum j equal 1 to n, but j not equal to I. So it will skip that one, and we'll have our xj minus m and all of that. And again, another parenthesis. Okay, so we can get this part out of here. And now notice we have, just kind of over here to the side, I have an a, that's my summation thing, over n minus 1, plus an a over, do I have a plus or a minus? Wait a minute. Look at that. I got a minus, minus, minus. And so I've got an a minus n times a over n minus 1 minus a over n times n minus 1. And so, those are those two summations up here, are the a's in this case. And so notice that if I get a common denominator, this becomes n times a and an n times n minus 1. And so this becomes a times n minus 1 over n times n minus 1. Well, those cancel and we just get a over n. So what this becomes up here is equal to, instead of 1 over n minus 1 times all this stuff, you get 1 over n times the sum I equal 1 to n of the xi minus m squared, and then minus this double summation down here. And the way the textbook ended up writing it was, they said, well, this is 1 over n times n minus 1, because we've got that up there. And then they just did a sum, and they said, instead of doing a double summation, which typically I would do 2 of the sigma signs, but that's okay. They just did 1, and they said, Well, I and j are both going from 1 to n, which they are, except that I can't be equal to j. Okay, we're going to skip those. And then they put together the xi minus m times the xj minus m. Okay, so this is in the textbook, and that's where they got to. And so we have that, and then if we want to take the expectation, okay, so the expected value then of s squared, when they do that, what they point out is that this term here. Oh, hang on, got to pause a minute. Okay, pardon the interruption. Let's see, where was I? Expected value of s squared. So we want to look at the expected value of this thing up here. And they mention the independence. So this, this part up here is the covariance stuff. And for independence, we have shown earlier that you get 0 when we look at an expected value here. Okay, so this just becomes 0. So really, we just need this expected value of this thing, and so that's the expected value of this 1 over n. The sum I equals 1 to n of xi minus m squared. So expected value says this is 1 over n times the sum I equal 1 to n of the expected value of xi minus m squared. And so this is 1 over n, sum I equals 1 to n of the expected value of xi squared minus 2xi m plus m squared, but that's 1 over n, sum I equal 1 to n of the expected value of xi squared minus 2 times the expected value of xi. Well, each of those, the expected value is m, the mean, so I get minus 2m squared and then plus m squared, all in that summation. And so 1 over n, sum I equal 1 to n of exi squared minus m squared. But see, that is just our definition of the variance of the x. And so since each xi is from the distribution x, so this is 1 over n times the sum I equal 1 to n of sigma sub x squared. But that means there's n of those, so we get n over n, sigma x squared. And finally, we get that the expected value of s squared is the variance of our original distribution that we're sampling from, sigma squared x. So a lot of algebra on that, and some tricky things that went on, but overall, I thought it would be good to kind of go through that whole thing and just see that yes, that indeed the expected value of this thing we call s squared, which is again s squared is the 1 over n minus 1 of the sum I equal 1 to n of the xi minus x bar squared. So when we do that and use the 1 over n minus 1, where one intuitively might expect to use 1 over n, actually, when we do this, then our expected value of this is indeed the variance of our population. Okay, so the sample variance has an expected value of the population variance. So there we go.